Hello and welcome to another My Engineering How-To video. My name is Mark, and for today's video I was given a broken door from a humidor. What happened here is it's not a wood, it kind of looks wood, but it's that compressed cardboard with a wood veneer. It's got a little bit damp and expanded, so it got stuck in the slot that it slides into. As a result, when someone was trying to remove it, part of it broke. So there's a few different ways that we can go about recreating this. The very first one is going to be, if it was an unbroken part, we can simply scan it with our 3D scanner and then send that file over to our 3D printer and we can print out a copy. We have done a video recently of it was a part of a broken roof from a Barbie dollhouse. What we end up doing is we scanned the whole thing, we mirrored the good half of the roof onto the bad half because it was symmetrical, and we were able to print out a perfect brand new roof. In this case, what I'm going to do is I'm going to actually reverse engineer this. So I'm going to create a CAD file of this on a reverse engineering software. And that way we can actually have a little bit more design intent behind it and make it symmetrical and essentially perfect. So the very first thing that we need to do in order to do that, of course, is get our template. So we're going to use our Scanology SimScan 42. I'm going to scan this in, and then we're going to export that STL file for reverse engineering. So anyone who's watched these demonstrations before knows that this is one of the quickest part of the whole demonstration is actually scanning the piece in, as long as you're using a Scanology scanner like the SimScan right here. First step is always going to be scanning in your targets. We hold the mode button. It's going to switch us into scanning mode. And then we just basically paint our object. So I've chosen to do 0.4 of a mil resolution just to make sure I get enough data on the sidewall of the piece so I get good cross sections. It will be probably a lot overkill in terms of resolution for what you need for reverse engineering, but the softwares that we use here at My Engineering are very robust. We don't really have to worry about overloading them on a piece this small. And that's it. So we hold our mode button again. I'm not going to worry about flipping this piece over in order to get 100% coverage because we just don't require that for this type of reverse engineering application. Last thing that we need to do before we export this is we just need to get rid of everything that we don't want in this scene. I'm going to use my black background plane function, and I'm going to select a bunch of these targets. It will fit the background plane to that and deletes everything below it. And we've got a little bit of artifacts over here. I'm just going to select those and delete. Now we can wrap it, which is how we turn it from raw data into a mesh. And there we go. This is the piece that we're going to use to reverse engineer. So I'm going to save this and export it. All right, so now I've brought our scanned model, so our STL file, into QuickSurface so we can reverse engineer it into a step file, a CAD object. Now, the very first step that I'm going to take is I'm going to use extract primitive, and I'm going to use our little paintbrush. I'm going to paint just some areas on the front of this that we're going to use as sort of our base plane. A lot of times if you're doing a project like this, you may want to actually align it ahead of time to the coordinate system, so you're actually using like the XY plane in order to extract. I'm actually going to forego that on this because it's not going to be necessary. This front face on this particular model is all that we're going to be using for our to be extracting our regular planes to create all of our CAD objects. And so just kind of selected some areas that we can get an average. I'm going to hit the plane function here. And now right away you can see how this object was never actually that flat to begin with. So you kind of have the object where it disappears, the scanned object disappears, so it's actually low. And here it sticks proud, so it's a little bit high. So it wasn't actually a flat object to start with. So we are actually going to create a perfectly flat object in our reverse engineering. So that's one of the advantages of creating a nice, perfect nominal CAD rather than just scanning and then sending that STL file directly over to the printer, because it's going to recreate all the imperfections that are in that piece. So I'm just going to hit create, and we have a nice little plane. Now I'm going to construct a second plane. And so I'm going to select from another plane. So I'm going to select plane 1. And I'm going to offset it by minus 3.7 millimeters. The reason I did that is on the piece, I didn't talk about this before, but I used a set of calipers to find the smallest thickness on the actual piece. because we know that's what's actually going to fit into the slides where this humidor little door actually fits into on the body of the humidor. As you recall, when we started this, the whole issue that we ran into was a little bit of moisture got into this sort of cardboard wood product. It swelled, it got stuck into the grooves that it slides into, and while trying to remove it, it ended up breaking. So we want to make sure that it is going to be the nominal thickness, and so I use the calipers to kind of determine 3.7 is the right number. So for minus 3.7, I'm going to hit OK. And so now we have a second plane, you can kind of see it here, and that is what we're going to use to get our overall thickness. So when we're doing our extrusions, we have a top plane and a bottom plane that we're going to be working up against. The last one that I'm going to do is this one up here. I'm going to do extract again. Just pick a few spots across here. Create another plane. Constrain it parallel to plane 1. I want to make sure that everything stays nice and parallel with our surfaces so that when we use the 3D printer, it extrudes everything in nice flat layers. You're not going to have that sort of stepping layer design. So now we have 3 planes, so that's going to be our extrusion limits for the whole body on this thing. The next step is going to be taking 2D cross sections and extruding the solid bodies that are going to make up this new piece. So first thing we want to do is our 2D sketch for extruded surface, and we want to use, let's say, our plane number 2. As you see, plane number 2 populates right here. And I'm going to go, oh no, not create yet, sorry. We're going to take this little arrow and we're going to drag it up because it's not on the plane where we actually want this to interact. We want to interact a little bit with the body itself. So I'm going to drag it up into the body so we get a good cross section of those sidewalls that we had created when we scanned. Now we can create. So now you can see the outline that we're using. I'm going to actually, for this one, I'm going to use a rectangle. I'm just going to go a little bit on the outside of our whole piece here. And I want to make sure that I'm staying on the inside of the top piece here. I'll get into that in a second. I'm just going to use my arrow now. So we can drag this and just kind of snap it on the body itself here. Oh, maybe a little bit out for that guy. And so this one can stand here or stay here because we're going to extrude this. It'll be actually inside the body of the little top piece, so the handle on here. So it's okay, we just, as long as it's closed off, so we have a nice solid extrusion. And so I can click the extrude button. And so this will interact now with the bottom of our whole scan. The top, I want to, oops, snap down to the wrong one. I want to snap it to that guy, so our top plane. So it was created on our bottom plane, number 2, and it's snapping to our top plane, number 1. And you kind of see a color map here, seeing how well it interacts with the data. I'm pretty happy with that overall. It's not really going to matter how well it interacts with the data at the end, as long as it's the right thickness overall. And you can see the depth here, 3.7. That is what I measured. That's what we want it to be so that we know it's going to slide in and out of the body of the humidor once we're done. Next, I'm going to do another 2D sketch. And we can pick, again, we'll pick the plane number 2. I'm going to drag it up this time. So we're interacting with just the top piece. And we want to make sure we kind of get it all. That's looking pretty good to me. And hit create. And so I'm going to use a different tool this time. I'm going to use extract primitives, fit line. I'm going to trace along this top one. It'll just fit a line there. Do the bottom one, fit a nice line there. A little bit of this side, a little bit of this side. So now we have 4 different lines here. So we can go back. I'm going to use this little tool here called auto join. Boom. It creates this nice little, automatically fits the rest of our lines, or creates nice little corners. And now we can go to extrude. So again, this is going to interact because we set the plane as our plane number 2, which is the back of our piece. So that's good. And I'm just going to take this and I'm going to snap it down to the top plane, which is plane number 3. So you can see how it interacts with the top here. And new solid. Actually, I could even go combine. Let's join. Make it one piece right out of the gate. Okay, so now we have the body and this top piece, which is the handle. If I turn off my mesh, you can see how it actually looks overall. It's looking pretty sharp. But next step, we got to create these little slots in here. I'm going to go to 2D Sketch one more time. I'm going to pick my plane number 2. And I'm going to drag this one up so that we get all these nice little slots. So the inside profile of those, and go create. And I'm going to use extract primitives. Instead of fit line, I'm going to use slot this time. And so I'm going to use the same kind of process we did on the top. We just highlight those particular areas that we want, and it will create a slot there. So I'm going to go ahead and do this for the rest. Now, these ones where it's broken, we don't actually have an entire slot to generate from, but what the software is going to figure out, we have enough of a profile here that we can probably figure it out. And you can see it did a pretty good job here. I'm going to do the same thing on this one. And again, we have a pretty good looking slot. So we have all these, they're all nice and parallel. And go back, and we're going to select extrude again. And instead of new solid this time, I'm going to use cut. And I'm going to run this one nice and wild to make sure that we cut all the way through. And we're going to hit OK. Now I'm going to turn off my mesh. You can see we have nice little slots cut in there. The last little thing that I'm looking at on here, it has very hard edges. And we're going to print it. It's going to look very much like this. We don't want it to be a hard little blocky piece, so we're going to make it look really nice. The one thing I'm going to do before we move on is we're done with all these planes here. We're not going to need them anymore, so I'm just going to hide them so that we're only looking at our piece. And now we're in the CAD tab up at the top. We're going to use fillet chamfer. I'm just going to go ahead and start selecting all the surfaces that I want to put a nice little radius on. We're going to be using the fillet function here. I want to use 0.5 because I think it looks nice. So that gives you a little bit of a preview. I think that's going to look great. We're going to hit OK. So filleting complete. Look at our part. Everything looks pretty sharp. So one last little thing that we can do before we actually do the export is we can turn on our mesh again and do a compare just to see how well we did overall. And you can see it actually interacts pretty good, even though that part was not that perfect to start with. I think we did a pretty good job. And now this is ready to go over to our 3D printer to make a new replica, very similar but improved, I would say, replica of the original piece. All right, so final results. Here is our original piece, the broken one. Here is our 3D printed piece. So they are virtually identical. You match them up side by side. It looks perfect. The added bonus is that this one is not going to swell as it gets wet and then gets stuck. So that's how we recreate something by reverse engineering. So we're not going to be just sending an STL file over to the printer. We're not going to be, because it was broken, just doing a mirror image of the good half on the bad half. We're actually creating a brand new piece based completely off the dimensions of the original piece, so that we have an absolute nominal perfect model of what this should have been in the first place. So that's it for today. Let me know your thoughts in the comment section below. And if there's any other workflows that you would like to see, make sure you reach out to us either in the comment section below, or you can reach us at support@myeng.ca. Make sure you like and subscribe so you can see more content like this, and we'll see you in the next video.